Hello and welcome to our two-part webinar series on the tomato brown rugose fruit virus. Since its first detection in 2014, we've seen this virus confirmed in many other parts of the world, leading to substantial impacts on yield and quality. Today we're going to be sharing the latest in management and preventative practices, and if you haven't already registered for tomorrow's session, we'll be talking about it from a grower's perspective. This webinar wouldn't be possible without the financial support of our sponsor, DeRuyter, who says, "At DeRuyter Seeds, we recognize seed health, and the rugose is an important and current concern in our industry, and we are delighted to collaborate to bring these webinars to you." DeRuyter, as part of the Vegetable Seeds Division at Bayer, offers seed for protected culture, both glasshouse and greenhouse cultivation. We are committed to bringing high-quality seed to your operation and to taking a proactive approach to supplying clean seeds. To bring our commitment to life, we developed SHIELD, Seed Health, Innovation, Excellence, Leadership, and Discipline. It is our comprehensive approach to delivering healthy seeds season after season. You can find out more about the SHIELD program on our DeRuyter website. We take great pride in our genetics, we invest in innovation, we strive to produce the best quality seed in the market, and we strive to deliver an excellent growing experience. All of this to work towards a shared goal of filling plates with healthy and delicious fruits and vegetables to those around the world. Today, we have the pleasure of hosting Cara McCreary, Greenhouse Vegetable IPM Specialist at the Ontario Ministry of Agriculture, Food, and Rural Affairs. Cara will be sharing the latest in rugose management and preventative practices. For those of you who have questions, send them to us as we go along using the questions box in the panel to your right, and we'll address as many of them as we can during the Q&A session. If your connection cuts out, don't worry, because a recording of this webinar will be made available online and a direct link will be sent to everyone who registered later this week. Without further ado, I'll hand the controls over to Cara.
Okay, thank you, Greta. Hello, everybody. Thank you for joining this webinar this afternoon. I'm very pleased to be invited to deliver this presentation today, and hopefully you will get some new information out of this presentation. Okay, so today, as Greta mentioned, I'll be talking about keeping out the rugose. So the focus really is on a bit of background, symptomology, transmission, and diagnostics. But ultimately, the focus today will be about crop protection, so some practical applications of some of the information that we currently have about the tomato brown rugose fruit virus, and the management, biosecurity, and disinfection information. And I'll briefly touch on a bit of future research objectives. Okay, so what is tomato brown rugose fruit virus? It's a plant virus that belongs to the family Virgaviridae. It also belongs to the Tobamovirus genus. So some of you that are tomato producers will probably be familiar with that genus, because in there is tobacco mosaic virus and tomato mosaic virus. And these are historically challenging viruses that producers have had to deal with in the past. There are a few others that are plant pests as well, like cucumber green mottle mosaic virus, and that belongs to the same genus as the tomato brown rugose fruit virus. So some of the key characteristics of tobamoviruses are that they tend to be very persistent in the environment, they're highly transmissible and easily spread mechanically, and they're very virulent strains that can be damaging to host crops. So these are major challenges when it comes to managing them with the persistence, the contact through crop work that can ease the spread throughout the crop, and the yield losses that are associated with this virus. So what crops are affected by tomato brown rugose fruit virus? Mainly what we know to this point is that it's mainly solanaceous crops that are affected by this virus, specifically tomato, but we also know that pepper can be a host as well. There are is some evidence and documentation of other species of solanaceous hosts, so specifically Nicotiana species, and that can include tobacco. There's some weeds, petunias, and other ornamentals that may also be hosts and act as reservoirs. And there were some studies that were done where certain species were inoculated by the virus, and eggplant and potato did not show symptoms in those studies. However, there have been some reports of infected eggplant coming from Mexico. But I think it's important to note a couple things. One is that although it seems to be most of the information is around solanaceous hosts, we have a lot of solanaceous weed species in our landscape in Ontario and elsewhere in North America. So these can act as reservoirs and sources of inoculum for our crops. So this is important to note. But the other thing is, I think we need to consider that we may not know the full host range, and that is something that is currently being investigated by several researchers across the globe. So what is different about this virus? So as I mentioned, many tomato producers and tobacco producers are familiar with tomato mosaic virus or tobacco mosaic virus, and there has been resistance, which was bred into most of our commercial varieties, but the challenge is that the tomato brown rugose fruit virus is able to overcome all known sources of genetic resistance that was bred for those other Tobamoviruses that we've dealt with in the past. Pepper resistance is, there are L genes that were used to in our commercial pepper varieties that are used for resistance against tobacco mosaic or tomato mosaic virus and pepper mild motto mosaic virus. And so far, the Rugose does not seem to be able to overcome those resistance genes, but more information is needed. Okay, so some of the symptoms of tomatoes, the foliar symptoms that are typical are chlorosis, a fern leaf, mosaic and mottling, and leaf narrowing. These are very typical symptoms of other Tobamoviruses as well. The calyx will tend to brown. There may be necrosis at the tips. The fruit can be blotchy, pale, yellow, or brown, have brown necrotic spots. This is a very distinguishing feature. The brown necrotic spots is what we call the rugose part. The fruit may be undersized, deformed, irregular maturation. There may be fewer fruit, or the fruit may abort. Some of these symptoms are a little bit tricky because there's a lot of other things that can cause irregular maturation or irregular ripening. So we have to be a bit careful when we're diagnosing just based on symptoms. The symptoms are also highly variable and can be very variety specific. So that's another consideration. There's a few damage estimates that are out there. There was some crops that documented about 10 to 15% symptomatic fruit. And I say 100 up to 100% here because if it is left unmanaged or unnoticed for too long, it can spread significantly to the point where the crop needs to be removed. So this quote is interesting. It came out of the American Seed Trade Association document that is available online. But it says that note that it has been reported that some varieties can develop a high virus level without physically expressing symptoms. Infected plants of these varieties can then unwittingly become a source for spread of tomato brown rugose fruit virus infection to healthy tomato or susceptible pepper plants. So I think the point of this statement is really to think about possible tolerance in some varieties and how there could be a viral load present without symptoms. So just because you can't see those symptoms, don't assume it's not there, and you still need to protect the rest of your crop, especially if you're growing tomatoes and peppers or different varieties of tomatoes that may be more susceptible than others. Okay, so pepper symptoms. We don't have as much information about pepper symptoms and infections in pepper crops, but in general, it's a similar sort of symptomology. So the foliar symptoms tend to be deformed foliage, yellowing, and mosaic patterns. The fruit may be deformed, yellowing or brown necrotic areas, or green stripes. Currently, there are no damage estimates available. There was some recent information, publication that came out of Israel where they documented infected peppers in some crops in Israel, but there were no damage estimates in that document. Okay, so how is tomato brown rugose fruit virus transmitted? So I'm just going to point to two main modes of transmission. So mechanically is one. So this can be through contact with people, hands, tools, clothing, chewing insects, birds, bees, grafting, roots, seeds, etc. Basically anything that comes in contact with the plant that has the ability to get plant sap on a tool or a person or an insect has the ability to transmit it to an uninfected plant. Seed transmission is another route. So this is one that has been implicated in a number of Tobamovirus or Tobamoviruses. But I think it's important to note that the extent of seed transmission for the Rugose virus is not well understood. So it's thought that it primarily resides on the seed surface and to a lesser extent internally. Dr. Aviv Dombrovsky from the Volcani Center in Israel has been studying this, and it's thought that the transmission rate from seed to seedling may actually be extremely low, but it's still ongoing trials and an ongoing investigation. So just to point out, in a commercial crop, the most critical way that it is spread and potentially how it's brought into the greenhouse would be through people. You know, in addition to that would be tools, clothing, and other things that people carry with them. But this is really ultimately what we think that we should focus on when it comes to prevention and management. So that's the segue into crop protection. So basically, you know, the key message here is that prevention is key. So everything and anything that can be done to avoid this virus from coming into your facility is critical. So I'm gonna outline a couple of specific things to keep in mind. So one is using certified seed. So when I say that, I'm talking about really the good seed and plant practices. So this is not technically a federal certification program, but it is an international transparent business chain system that was developed in response to bacterial canker. So that's a bacterial disease of tomatoes, but it is also highly transmissible. So a lot of the practices that are used in this program would be helpful. It is not specific to the Rugose, but we know that most of our major seed companies are working diligently, you know, on those types of things. So next, practicing strict sanitation at all stages of crop production is critical. All workers and visitors should practice strict hygiene. Thorough hand washing. I'm sure everybody has heard a lot about thorough hand washing recently. This is a really critical piece that can protect your crop from the Rugose virus. Freshly laundered uniforms or clothes, footwear that remains on farm. So this can be a very important piece to not have clothing and footwear that leaves the farm and then comes back. So having things that are remain on farm, are laundered on farm or cleaned on farm can be critical part of the prevention program. Being mindful of people moving from farm to farm. So this is really important, you know, to have workers that are dedicated to a specific greenhouse and not moving from greenhouse to greenhouse. Some of this may be challenging for field producers, but in this topic, I'm talking specifically about greenhouse production. When people visit the farm, providing disposable lab coats, gloves, followed by disinfectants if handling the plants can help. For those visitors who need to visit more than one operation in the same day, in this case with the Rugose virus, it's probably best to limit or eliminate visiting the same crop in the same day. And of course, go home and shower. So hygiene, hygiene, hygiene. I think sometimes with a virus like this, there's a tendency to want to just lock your doors and not let anybody in. But I think that's not the message that we're trying to get out right now. It's not about closing your doors to everybody, because there are a lot of people out there that can provide value to your farm. So just recognizing those people and making sure that you take appropriate measures to protect your crop is important. So hand washing, as I mentioned, I'm going to talk a little bit more about some research that was done around hand washing momentarily. But this is absolutely one of our critical factors of reducing transmission. A few other things to point out. Conducting a thorough clean out between crops is important. I'm not going to go into a ton of detail about the clean out between crops, but I just want to point that out. Managing imports is another thing that can be identified as a risk factor, especially if there's packing facilities that are attached to or directly beside production facilities. Another thing during crop work, when deleafing, trying to practice clean breaks as best as you can. Most pathogens need some sort of wound site to infect the plant, so minimizing the wounds and practicing a clean break, preferably deleafing in the morning so the leaf node can dry out by evening. These are all things that can help maintain healthy plants. And then disinfection, there's a lot of questions around disinfection. I will talk a little bit more about that later. But in general, using foot baths, tire baths, hand sanitizer, and refreshing those disinfectants regularly is important. Cleaning equipment, vehicles, parts, tools, and maintaining clean irrigation water, especially in our closed systems. There's a number of ways that we can sanitize our irrigation water, and I'll talk a little bit more about some options there. But basically ensuring all workers and visitors follow strict biosecurity. So this here on this screen is a greenhouse visitor biosecurity guide that was developed by the Ontario Greenhouse Vegetable Growers, which is our local growers association for greenhouse tomatoes, peppers, and cucumbers, and in collaboration with a number of others. This is basically a handout that a greenhouse can give to a visitor outlining their expectations. And so this is a bit, I think, a piece that gives them, maintains some sort of authority in demonstrating an expectation that your visitors follow this protocol before, during, and after they leave. So there is a link that I'm not going to go through all those points right here. But on this slide, you can see there's a link to OGVG's Visitor Biosecurity handout through the Hort Council website that it can be downloaded. And of course, I'm sure if anyone's interested, you can reach out to OGVG directly. There's also a couple of other links on here that I just want to point you to for extra information on biosecurity. So there's CFIA's Plant Health Biosecurity Guide. And then at the bottom there, you can see one that's a bit more specific to the vegetable sector, greenhouse vegetable sector. So there's a lot of really good information on those websites. There's checklists and all sorts of other things that you can go through to evaluate your biosecurity and identify some areas that could use improvement. So now I'm just going to walk through a few steps of managing a plant virus. And each of these I'll go through in a bit more detail. So the first is practicing strict biosecurity. So this is a common theme in a lot of our virus management documents. So I just have a couple of examples there of some things that can be done with a biosecurity lens. So on the top left, right here, you can see this is literally just a boot scrubber. So anyone entering the facility can rub off some of the hard organic matter that's stuck to the bottom of their shoes. This one in the center at the top is a more fancy boot scrubbing equipment. There's a couple other things to consider. So if you have some sort of staging area for employees to change when they arrive, leaving their outdoor shoes in there, changing into a uniform, or changing into their work boots or something like that. You can maintain a little bit of separation as far as what is being brought into the greenhouse from outside. And I know after talking with some people that deal with livestock, they have some strategies where employees will sit on one side of the bench, take off their outdoor shoes, swing their legs over to the other side of the bench, and that's where their indoor shoes are. So just being mindful of a couple options. There are, of course, disposable suits that can be worn, especially by visitors or workers that are working in areas that may have an infection, and of course, hand sanitizer. So now I just want to talk a bit about some practical alternatives if you don't have this big fancy boot washing equipment. There are some things that can be done and that would take minimal time and effort by employees on the farm. And I'm specifically pointing out some of these things because as specialists within OMAFRA, we have this protocol ourselves. So for any of us that visit field sites or different farms or conduct surveys or things like that, we have disinfection biosecurity protocol. So I'm just going to go through a few options as far as cleaning your shoes, the bottom of your shoes, if you don't have work boots dedicated to the farm or big fancy boot scrubbing equipment. So there's just a few things you'll need: water, soap, a scrub brush, disinfectant, and then buckets and a spray bottle are optional. So first, the first step is to remove the debris and dirt on the underside of your shoes. So a lot can get captured in the bottom, and that organic matter can house a lot of different pathogens, but bringing any sort of material into the farm and throughout the farm increases your risk of transmission. So once the dirt has been removed, preferably with some soap and water, rinse with just plain water before proceeding. Next, dissolve some disinfectant in a separate clean bin and submerge the boots. Alternatively, you could spray the boots directly with disinfectant, but contact time is actually a really important piece of the efficacy of disinfectant. So if you're able to submerge them for a period of time, the disinfectants will have more of an opportunity to do their job. So the next, well, it's part of step one still, but I've already mentioned this, but I just want to talk a little more about washing your hands, because this is a very critical piece in transmitting plant viruses in the crops. So Dr. Adrian Fox, who's a principal plant virologist with Fera Science in the UK, has been kind enough to share some of his information with us about some trials that he's conducted. So first, he investigated the survival of the Rugose on skin and gloves. So what he did was basically transferred the virus through infected sap to hands and gloves. So that's how the hands and gloves were contaminated with the virus at 15-minute intervals up until 1 hour. And then after 1.5 hours and after 2 hours, those hands and gloves were swabbed and tested for the Rugose. So how they did that, there's a couple different ways that they tested for it, but they tested, the main way is through a bioassay. So they take that swab and then they try to infect a plant with it to see if the virus is still viable after those periods of time. So they left those plants for up to 3 weeks and monitored them, and then harvested those plant samples and tested for presence of the Rugose virus. They also repeated that same trial, but using contact transmission from an infected leaf. So rather than transferring infected sap to the hands, they had those hands actually just handle infected leaves. So the results from that study, they stopped after 2 hours, was that even after 2 hours, that all the virus that they found on the hands and gloves was still viable and could infect plants. So this piece basically just tells us how important it is for us to be mindful of our hands and what we have, what we are handling after we handle plants. So then he did some hand washing trials. So here he investigated different methods of hand washing in order to identify some areas that can reduce the risk of contaminating further. So again, these hands were contaminated with an infected leaf. So there were 2 separate trials, one where the hands were washed for 30 seconds, another where they were washed for a minute. The treatments included water, soap, medicated hand wash, and medicated hand wash followed by a gel. Then the hands were swabbed and inoculated test plants, just like in the previous study. So with the results from this trial, after 30 seconds, all the hands were still contaminated, regardless of the treatment that was used. After 1 minute, the only treatment that still had viable virus was the medicated hand wash. So the other 3, there was no viable virus found. So these conclusions are difficult because we can't exactly point to one option that's better than others. So the theory is that a lot of the removal of the virus from the hands may actually be due to rubbing action. And so this is an important piece because I know there's lots of really interesting videos that I've seen that are science-based on YouTube about proper hand washing. And a lot of it comes down to, what we see in the movies when we're watching doctors wash their hands or surgeons wash their hands before they go into an operating room, and how they literally scrub. So they scrub with their nails, they scrub with their fingertips, they get into all the nooks and crannies of our hands. They try to dislodge residue and organic matter. It lifts up the pathogens and washes them away. So, using soap, using medicated hand wash or hand sanitizer is still good, but we really have to focus on how we're washing our hands and trying to get that rubbing action in there. So ultimately, the recommendation that's coming out of Fera Science is that washing your hands is still important, but you should wear gloves when handling plants and change them often. So the second step in managing a virus is to quarantine known or suspected plants. So basically, assume that it is. So if you find a suspicious plant, just assume that it is. Flag that plant, restrict access immediately, preferably designate specific workers and equipment to that area, and manage the workflow. So make sure that the workers are working in the same direction, one direction all the time, and then save that area to last. Once you've done that, that's a critical step because you want to minimize the spread, but now you ultimately need to properly diagnose it. So how can we properly diagnose? The Rugose I know that there have been scientists and companies working on immunostrips, so these are ones that will be available on farm for quick diagnostics. In the meantime, it's really important to send it to an accredited diagnostic lab. And for those that are Canadian residents, it's important to keep those samples inside our borders, and that would go for other countries as well. So you want to send it to a diagnostics lab within your own country. There's a couple, I'm not going to get into a lot of detail about the different diagnostic methods, but there are several out there. So there's conventional PCR, there is real-time PCR. I think what we've used in Canada is the conventional PCR that was developed by Dr. Ling from the USDA. And some of the strategies now are to run multiple tests. So run a conventional PCR, a real-time PCR, and follow positive results with sequencing. And this way we can be certain as to what we're dealing with. It's also important not to rely on only one sample. So especially for positive results, to send another sample in to get a second result out of it is important. And so why do we want properly diagnosed disease? It's because we need to ultimately know what it is. So if it is the Rugose, we need to know that so that we can deal with it properly. And once we know what it is, then we can investigate and have more information about it. So how is it transmitted, and what can we do to prevent it from spreading through the crop? So the next step would be to remove the infected plants. And actually, if it is a suspicious plant, you wouldn't want to wait for your results. You would want to do this right away. So removing the infected plants immediately is really important. Depending on the disease with the Rugose, it may be important to remove a number of plants surrounding that infected plant. And ultimately, if you think of the direction of the workflow, that is going to be a reasonable direction that the plant would spread. So from the point of infection, perhaps removing some plants prior to that, but really focusing on removing some and scouting the areas following the workflow. And then, of course, proper disposal of all plant material is critical. We don't know really how this virus would survive on plant material outside. So dumping the plant material in the field or spreading it in a field behind the greenhouse is not recommended. It should be disposed of to landfill or buried deeply so that it won't be exposed. So now I'm just going to walk through a couple of visual steps on how to properly remove an infected plant from the crop. So of course, following all biosecurity protocol to prevent further transmission. The reason is anything that comes in contact with an infected plant can potentially transmit it to other viruses. So you want to be really mindful of what touches that plant as you're removing it. I personally think that it's much easier to do this in pairs if you have the labor. But basically you start by cutting the plant free from its support system and disinfecting those scissors. So remember, contact time is important for a lot of viruses, a lot of pathogens, including some viruses. We may not have the exact amount of time yet with the Rugose, but more time is typically better, just being mindful of some of the corrosive disinfectants. Once you've cut it free, use a knife and cut the block free from the slab. And then, of course, disinfect the knife properly. If you have a team, having one person holding open the garbage bag while the other tries to direct the plant inside is really helpful. And the reason for that is because then you don't run the risk of having the plant rub the outside of the garbage bag and then you're dragging it down the row, potentially transferring viral particles to uninfected plants. So these are just a few photos of what not to do. So using bare hands and not being dressed appropriately, dragging an infected plant down the row, and just leaving it in an open garbage container. So these are all risky factors. So another thing that's important for managing plant virus like the Rugose is to clean and disinfect regularly. So as I mentioned, basically anything that has plant sap on it can hold the virus. So tools, equipment, pathways, especially those that may be in or near an infected area. So I know, for some producers, they may say, but I have 2,000 picking crates. How can I clean those regularly? These are all things that we would like to find some really practical solutions for, but with, a highly transmissible and risky virus like this, there may be a need to just put more effort and more labor into keeping things clean and disinfecting regularly. So one thing when we talk about cleaning and disinfecting, I just want to point this out as a really critical factor, is removing organic matter prior to disinfection. And there's a really good reason why we need to do that. So for one, organic matter provides protection for pathogens. And another is that in some cases, it may chemically bond with a disinfectant, and this could inactivate or neutralize that disinfectant. So basically, you would be wasting time and money by applying a disinfectant to a pathogen that's protected by organic matter. And just to give you a little visual, imagine yourself standing outside and imagine that it starts to rain. So what would happen? You would get wet, right? But imagine yourself standing outside and you're protected from a tree. And so this is your organic matter here. And it starts to rain. You're not going to get wet. And so that's just to give you kind of a visual of those viral particles and being protected by the organic matter. When you apply the disinfectant, it won't even touch them necessarily. So Dr. Adrian Fox, again, he conducted some survival trials on various greenhouse surfaces and tools. Some of the surfaces that he tested were glass, concrete, aluminum, some hard plastics like picking crates, polyethylene, and stainless steel. These are ongoing trials, but so far they have swabbed at 2 hours, 8 hours, 48 hours, 7 days, and 4 weeks. From there, they're going on to 3 months and then 6 months. So far, the viable virus has been detected on all of those surfaces at 4 weeks, with the exception of concrete. So after somewhere between the 7-day and the 4-week swab event, the virus on the concrete was not viable. So this is an interesting finding because concrete tends to be one of the harder surfaces to clean and disinfect because of its porous nature. So next, I just want to talk a bit more about other surfaces that you should think about for cleaning and disinfecting regularly. And as I mentioned already, what do your hands touch after they touch plants? So there's been some cases with the Rugose virus, but also other closely related viruses where the virus has been found on various surfaces that may not have been considered before. So an example would be things like bathroom doorknobs. So a lot of people will touch those doorknobs. Keyboards or a mouse in office where growers or scouts or anybody may have access to. Lunchrooms, lunch tables, anything that hands come in contact with. So in this photo, I just have disinfection wipes. The rubbing action and just trying to maintain some cleanliness and disinfection regularly is better than doing nothing. So now I just want to talk a bit about pasteurization and heat treatment. So this may be an important factor to consider for a number of reasons. So we do have some producers locally that use pasteurizers to disinfect or clean their irrigation systems, especially in closed systems. But it's also an option for our local organic producers. So in Canada, our organic producers use soil-based media. And so pasteurization is an option to sterilize that soil, or heat treatment are an option to sterilize the soil between crops. So in this table here, I've just pointed out just in general some different temperatures and time contact, or amounts of time that it needs to be exposed to that temperature to kill certain organisms. So you can see bacteria, it would take 60 degrees Celsius for 10 minutes to kill a lot of the bacterial organisms. So we might deal with botrytis, which is a fungus, 55 degrees for 5 minutes. Pythiums and oomycete, 46 degrees for 40 minutes. Insects and mites, and then weeds. These are weeds we don't tend to deal with too much in our greenhouse production systems in Canada, but you can see the temperature increase there. So this next table just identifies more appropriately some viruses, and this specifically, their exposure time is 10 minutes. And so you can see Mosaic virus at 65 to 70 degrees Celsius for 10 minutes is what it would take to denature that virus. Tomato spotted wilt is much lower, 45 degrees Celsius for 10 minutes. But if you move down to the bottom of the chart, this is where we have cucumber green mottle mosaic virus. And if you recall, that virus belongs to the same genus, the Tobamovirus genus, and the temperature requirements there are quite high, so 90 to 100 degrees Celsius for 10 minutes. So the reason, that we look to something like this in the absence of a lot of research results or information about a new virus, we may look to closely related viruses to get some sort of information that's practical for our producers. So that we flagged, and now Dr. Adrian Fox again has conducted some hot water treatment trials that I will share with you today. So in these in particular, he investigated hot water treatments for contaminated trays, and by trays I mean picking crates. In the UK they call them trays. So our picking crates, the picking crates he tested were contaminated with infected staph, and then they were swabbed, so prior to any treatment. There were 2 temperature regimes he used, 70 degrees Celsius and 90 degrees Celsius for 5 minutes. Then those trays were swabbed again. Then those trays were sprayed with Virkon, which is a disinfectant, and left for 1 minute. So that's 1 minute contact time. And then they were re-swabbed. So the results for the 70-degree treatment alone was that there was still viable virus on those picking trays. Once they, at 70 degrees followed by Virkon, there was no virus detected. And then at 90 degrees, with or without Virkon, there was no virus detected. So this supports some of what we knew about some other Tobamoviruses like CGMMV, but the higher the temperature, the more likely to denature through hot water treatment. So next, I just want to talk a little bit about where to focus. So I think sometimes this can appear to be really overwhelming when you think about all of the things that you touch with your hands and these microscopic viral particles that could be anywhere. But ultimately, you just need to start somewhere. So start with the riskiest areas, the areas where most people come in contact with, and start there. And then, slowly incorporate different and new areas into your cleaning program. So this, I just want to point out a study that was conducted by Dr. Walid Alouz in 2017. So this was specifically, he was looking at CGMMV, but a closely related virus. He swabbed a number of different surfaces and identified some areas that had a fairly high viral load. So some of those I think we would expect, and some were maybe a little bit surprising, or things that we wouldn't have considered before. So tools, of course, picking crates, wood pallets, door handles, and forklifts, especially the fork. So these are some areas that you may want to start with, and then incorporate some other areas into your program eventually. Okay, so the next step would be to monitor diligently. So once you have it confirmed, you've taken all the right precautions, quarantined it, isolated it, and you're beefing up your cleaning and disinfection programs, you want to keep a close eye on that area. So as I mentioned before, we know that this is spread mechanically, and that employees, anyone who comes in contact with those plants, has potential to spread it. So we need to focus on the spread in the same direction as the workers. So having some diligent scouting programs, flagging, and investigating those areas is critical for continued management. And of course, if more infected plants are found, return to step 2. So this last one, step 7, conduct a thorough cleanout between crops. This is basically, I'm not going to go into a lot of detail. A lot of it we've already talked about as far as some of the protocol. But really, just if there's one thing I hope you can take away from this, is the importance of following these 3 steps when you're cleaning anything. So removing organic matter first. So this can be done with soap or some sort of detergent, and then disinfecting finally. And so some additional things to look at, are disposing of the crop properly, maintaining warmer temperatures during cleanup. I know this is sometimes a difficult decision for producers, especially in our Canadian climates where we have really cold winters, and a lot of our cleanouts tend to happen through the winter months. But it actually makes for much more effective cleanout programs, and there's a lot of disinfectants that work much better at warmer temperatures. So it's something to consider when dealing with something that's difficult, like the Rugose virus. Maintaining clean irrigation systems, and doing a thorough cleanout of the irrigation system at the end of the crop is important. Cleaning, rinsing, and disinfecting both the equipment and the structure. And then just keeping in mind some of the factors that influence the efficacy of your disinfection program. So organic matter, temperature, contact time, the concentration, drying time, and the type of surface are important. And I am going to talk in a bit more detail about disinfectants. So there's several groups that we tend to use in Canada. So I've just listed them there in that chart. Some of them have consistent results against viruses, and some don't. That doesn't mean to say that every product that falls in that group does not work against a virus. It's just being mindful of the specific products that you're choosing. And then I just want to present a little bit of results from Dr. Adrian Fox's disinfection trials. So here he looks at Virkon, sodium hypochlorite, which is bleach, trisodium phosphate. Those 3 are available in Canada. The next 3 are not, so I just want to point that out. So most of them are products that are being explored in other countries, and we're trying to stay on top of it. But I just want to make sure that for our Canadian residents or any participants who are from other countries, that you keep that in mind, that you need to use appropriate disinfectants that are approved by your country of residence. So we tested similar surfaces, glass, concrete, aluminum, hard plastic, polyethylene, and stainless steel. They were swabbed after 1 minute, so that's 1 minute contact time. There are ongoing trials looking at 1 hour contact time, but to date, they only had the results for the 1 minute contact time. And ultimately, none of those products were effective after only 1 minute on any of those surfaces. So The next step is to evaluate an hour contact time. If the products are effective at an hour, then they will work their way backwards to see what's the minimum contact that's needed. And then this quote, I love this quote I found it in a Horti Daily article from Dr. Davino in Italy. None of the actors, seed companies, nurseries, gardeners, producers, distributors can avoid implementing all preventative containment measures. If only one link of the chain fails, it risks putting the entire Sicilian tomato production at risk. But I think this is a really good point, that something like this is a community pest, and it's really up to us, up to everybody that's involved with the greenhouse sector, to take some ownership of it and to take some responsibility to do all the right things and support our producers. And so there's a lot of research, ongoing research that's going on across the globe. Many researchers are looking into host range. Vaccines are a definite possibility. And then, of course, there's more information that will be coming out, hopefully in the near future, about disinfectants and what works and what doesn't. And then, of course, the end game, there's breeders and our seed producers that are working to develop resistant varieties. So the take-home message really is biosecurity is your first line of defense. And although it's overwhelming to focus on the riskiest pathways first, think sanitation, disinfection, and hygiene. And then for any producer that's dealing with this, it's really helpful to establish a support network. So that could be any number of people in the supply chain, government, grower organizations, IPM specialists, suppliers, or consultants. And be empowered, because you are the ones that need to protect your crop.
And that's all the time we have for today. Thank you to Cara for sharing her expertise with us. Thank you to our sponsor, DeRuyter, for making this webinar series possible. To our audience, if you haven't already, be sure to register for part 2 of our webinar series happening tomorrow with Dr. Mike Bledsoe of Village Farms, who will be sharing their experiences since the U.S. federal order was introduced last November. Now, if we didn't get to your question, we'll post the answers online directly, and a recording of this presentation will be made available online later this week. A direct link will be sent to everyone who registered. Bye for now.